Welcome to everybody, and we have the pleasure today to receive Thomas Ryckman, who is professor at the University of Stanford, and who is going to speak about Niels Bohr, Transcendental Physicist. So Thomas, it's up to you now. Thank you.
Well, thank you very much. It's a great pleasure to be back in Paris to see many old friends. This is a title of a talk that I've given several times, but the talk is rather different. It's really the précis of a book that I'm writing on Niels Bohr. It's a very broad, structured talk, and this is what it's going to look like. I have 4 parts, and I've partitioned Bohr's writings on philosophy and physics into two areas, with the dividing line around 1935. That, of course, would be EPR and his response to EPR. But the first period from the Como lecture to 1935, I'm calling Bohr's Transcendentalism. Then I'm just going to briefly cover some very familiar territory for all of you, so I won't linger on it. Bohr against EPR in 1935. And then the elaboration of what I'm calling Bohr's Transcendentalism from 1949 to 1962, when Bohr died in 1962. And finally, I'm going to look at the writing a little bit, just a glimpse at what John Wheeler did with Niels Bohr and how he understood Bohr. And I think the way that Wheeler understood Bohr is very akin to what I'm trying to tell you today. So here we go. Transcendental. Well, we know that the Copernican revolution in Kant was the beginning of transcendental idealism. It's maybe worthwhile reading this. Maybe physicists don't know this passage. It's one of the most famous in all of Kant. It's from the introduction to the B edition of 1787. Up to now, it has been assumed that all our cognition must conform to the objects, but all attempts to find out something about them a priori through concepts that would extend our cognition have on this presupposition come to nothing. Hence, let us try whether we do not get further with the problems of metaphysics by assuming that the objects must conform to our cognition. That's the Copernican turn, which is to establish something about objects before they're given to us. And here is you can find several in Kant. This is the one that I prefer from the Prolegomena. The word transcendental does not signify something passing beyond all experience, but something that indeed precedes it a priori, that is intended simply to make knowledge of experience possible. And finally, and this is the real parallel with Bohr, because I think that Bohr is doing something almost as general as Kantian transcendental idealism, which is to transform fundamental concepts of epistemology, metaphysics, and semantics. And these have to do with concepts like objectivity and knowledge, subject and object, and reference and meaning. The latter part was really the contribution of Neo-Kantians, particularly Cassirer. I want to stress, however, that Bohr did not come to his transcendentalism, what I'm calling Bohr's transcendentalism, from philosophy. It's completely sui generis. He arrived at his transcendental conclusions, which I'm going to call, for the purpose of lack of a better word, small metaphysics, through the quantum theory, not through philosophy. The a priori is very much changed here. It's not something that precedes all experience. It's something that we've picked up from experience. And this is actually a meaning of the a priori that was already in Neo-Kantians like Hans Reichenbach. Well, you might search the woods for transcendental physicists. Here's one of my favorites, Heinrich Hertz, and the famous Hertzian conception of physical theory from his introduction to the posthumously published Principles of Mechanics. Maybe I'll read this. I have a diagram which illustrates it. We form for ourselves apparent mental images or symbols, innerlich Scheinbilder oder Symbole. So Scheinbilder is a term from the German stage, illusion, things that happen on stage. I learned that. Of external objects, and the form we give them is such that the necessary consequence in thought of the pictures are always the pictures of the necessary consequence in nature of the objects pictured. The pictures which we speak of are our representations, Vorstellungen of things. They are in conformity with the things in one important respect, namely in satisfying the above-mentioned requirement, that is, agreement with the phenomena. For our purpose, it is not necessary that they should be in conformity with the things in any other respect whatsoever. As a matter of fact, we do not know, nor have any means of knowing, whether our representations of things are in conformity with the things themselves in any other than this one fundamental respect. So that's a Kantian move, transcendental move. And here's a diagram, crude, of that conception of physical theories, and I call this a diagram of small metaphysics. Here you see, starting on the left upper corner, we have the terms of physical theory. These are the symbols or the inner Scheinbilder. We draw logical and mathematical inferences from them, so these are the necessary consequences in thought. Those are predictions, if you like. Of course, the physical terms are supposed to represent external objects, and the putative causal relations from the hidden external objects produce the necessary consequences in nature, the phenomena. So if you chase around that diagram, you can see that everything is going to be the agreement of thought with the phenomena. Quantum theory, according to Bohr, provides an epistemological lesson with bearings on problems far beyond the domain of physical science. And I want to underscore that because that's why I'm making this very broad claim about the significance of what Bohr is doing in philosophy. I think Bohr himself viewed it that way. And the lesson is contained in drawing out consequences of what Bohr called the quantum postulate, symbolized by Planck's quantum of action. And Bohr saw this as the essence of quantum theory. Well, that's the quantum postulate, just Planck's constant h. And you notice that it's expressed in these pre-quantum mechanical Einstein-de Broglie relations, linking dynamical and kinematical quantities. And Bohr says about this, this is in his Como lecture from 1927, the quantum postulate attributes to any atomic process an essential discontinuity, or rather individuality. That's an important rather, individuality, what counts as an individual object, completely foreign to the classical theories and symbolized by Planck's quantum of action. Well, I know a lot of you know this material quite well. Why did he call it a postulate? Planck's constant is a physical fact. Well, he elevated it to the status of a postulate or an axiom because the conclusions that he's going to draw from it were going to, in his own view, transform fundamental concepts of epistemology, semantics, and even metaphysics. And those are the very notions that we saw Kant engaging with transcendental idealism, including now reference and meaning. And in particular, it's necessary, according to Bohr, to renounce, that's one of Bohr's favorite words, renounce classical presuppositions of this ontological or semantic picture of a physical world wherein individual entities or systems can be theoretically assigned definite states, assumed to completely describe those localized real states of affairs in which the designated entities possess pre-existing properties with definite values. And these are properties whose obtaining explains the value yielded in a measurement outcome. And for Bohr, this is going to be a metaphysical fairy tale. Just like, as Hertz said, it's going to be something that we have no way of knowing. So we can dismiss it from science. And the argument that Bohr gives against this classical picture in the Como lecture can be pretty easily summarized, and I'm skating over material that you all know. Let's just remind ourselves, Bohr says that the concept of observation has been changed in the quantum theory. Our usual description of physical phenomena is based entirely on the idea that the phenomena may be observed without disturbing them appreciably. But the quantum postulate implies there's this non-negligible interaction in observation, and Bohr concludes, therefore, no independent reality in the ordinary physical sense can be ascribed to the phenomena or to the agencies of observation. And in this passage, it's interesting to note this is early Bohr, early complementarity. and Bohr and complementarity are not exactly the same thing, although people often allied the distinctions. But here, Bohr does not meld together phenomena and agencies of observation. They're two different things. The phenomena pertains to the target system, the agencies of observation to the apparatus in the lab. These are going to be joined in his redefinition of phenomena after 1935. The argument is slightly expanded, well, considerably expanded in 1935 with the appearance of the EPR paper. I'll say a few words about that, not too many, because again, it's all so familiar to everyone here. So the elimination of all external disturbances presumed in the definition of physical state of a system as ordinarily understood. But according to the quantum postulate, such a definition for quantum phenomena means any observation is impossible. To be well defined, a measured observed state must take into account measurement, procedure, and context. And in 1935, Bohr makes an explicit definitional requirement of contextual attribution of properties to systems, extended to all states, not just measured states, to all states, including those that are merely predicted, as in the EPR system 2, where no measurement is made but you can infer properties on system 2 by making measurements on system 1. And so he concludes, the procedure of measurements has an essential influence on the conditions on which the very definition of physical quantities in questions rest. That's the first real characterization of this new notion of phenomena. Let's remind ourselves of what's going on in EPR, famous paper, Can Quantum Mechanical Description of Physical Reality Be Considered Complete? You probably all know that the paper was written by Boris Podolsky, not by Einstein. Einstein wasn't very happy with the way the argument went in the paper. We can talk about that later if you like. But in the very first paragraph, it stated, any serious consideration of a physical theory must take into account the distinction between the objective reality, which is independent of any theory, and the physical concepts with which the theory operates. These concepts are intended to correspond with the objective reality, and by means of these concepts, we take this reality, we picture this reality to ourselves. So that is the classical ontological picture of reference and meaning that you get from EPR. You can see this articulated elsewhere in EPR in the infamous criterion of reality, and also later in works by Einstein. Remember, the criterion of reality runs like this. If, without in any way disturbing a system, we can predict with certainty, probability equal to unity, the value of a physical quantity, then there exists an element of reality corresponding to this physical quantity. That was actually the target of Bohr's reply to EPR in 1935, the criterion. He says it contains an essential ambiguity. We'll see what that is. And then Einstein, writing some years later in a Festschrift for Louis de Broglie, there is such a thing as the real state of a physical system existing independently of any measurement or observation that in principle can be described by means of expression in physics. And you can see now how the Bohr contextual attribution of properties is going to conflict with this ontological picture of, we'll call it property realism. I actually find this little note that Bohr wrote in Nature before his paper in Phys. Rev came out in 1935. This little note appeared in Nature, just one paragraph, and where it points to a new definition of physical reality. I should like to point out that the EPR criterion of reality contains an essential ambiguity when it is applied to problems of quantum mechanics. A closer examination reveals that the procedure of measurements has an essential influence on the conditions on which the very definition of the quantities in question rests. Since these conditions must be considered as an inherent element of any phenomena to which the term physical reality can be unambiguously applied, the conclusion of EPR, that quantum mechanics is incomplete, does not seem to be justified. A fuller development of this argument will be given, and that's a reference to the paper that comes out in Physical Review a few weeks later. Now, Many people read Bohr, I think wrongly, but for a long time as being an instrumentalist or some sort of positivist. I think if you just focus on this one passage, you can see that the fundamental thing is not what we can observe or not what we can measure, but it's on definition of physical quantities. That's extremely important for Bohr, because without well-defined quantities, we can't have property attribution. So, unrestricted property attribution, so giving definite values to these kinematical dynamical variables, as EPR does, involves an essential ambiguity, since the attribution necessarily refers to conditions of epistemic accessibility. That is, the experimental conditions in which the information about the system is obtained. And property attribution can only be made after a microphysical object system has made contact with physical reality, that is, with the laboratory setup and the apparatus. The value of the property attributed to the quantum object as a result of measurement cannot be regarded, therefore, as an intrinsic property of the object itself, but only of its behavior manifested observationally when placed in a given experimental context and a result recorded. So this property attribution requires epistemic accessibility. And the property concept now is going to refer to the entire phenomena of which the target system is a non-separable component. And so the attribution only indirectly represents a property of the target system, because the target system is just a component of a larger system. Now, Bohr's argument in EPR has been very badly treated, although I think a lot of people accepted it. John Bell says famously, while imagining that I understand the position of Einstein as regards the EPR correlations, I have very little understanding of his principal opponent, Bohr. Yet most contemporary theorists have the impression that Bohr got the better of Einstein in the argument and are under the impression that they themselves share Bohr's views. Well, and I think that the difficulty of many physicists and philosophers in understanding Bohr and the willingness to attribute to Bohr these instrumentalist and positivist characterizations is simply from the grip of a realist semantics that these philosophers and physicists have. I think they're really quite unable to think outside of that change in semantics, where that they're unable to think outside of that classical picture of reference and meaning. E.T. Jaynes is another one. He called it the principal task of quantum foundations to unscramble Bohr's omelet, essentially to recover property realism. He writes in, this is in 1990, a conference in Santa Fe, our present quantum formalism is a peculiar mixture describing in part laws of nature and in part incomplete human information about nature, all scrambled up together by Bohr into an omelet that no one has seen how to unscramble. Yet we think that the unscrambling is a prerequisite for any further advance in physical theory. And if you read James a little bit more fully, you'll see that what he's really talking about, that the unscrambling is to recover this unrestricted attribution of properties that I'm calling property realism. Now in the third part of the talk, I'm going to talk about the elaboration of this argument, which I think where Bohr adds a number of pieces that were only implicit in the earlier discussions stemming from the Como lecture and going up to 1935. And the principal texts here are, of course, in 1949, his discussions with Einstein, that's published in the epistemological discussions with Einstein, that's published in the Schulp volume, to which Einstein replied, going up to some smaller philosophical but very rich papers in Bohr, up to his death in 1962. And as I see it, Bohr states the fundamental issue this way: the problem of how objectivity may be retained during the growth of experience beyond the events of everyday life. A second quote that I'm going to revolve around is one that is not directly from Bohr, but attributed to Bohr by Aga Pedersen. We are suspended in language. Our task is to communicate experience and ideas to others. We must strive continuously to extend the scope of our description. but in such a way that our messages do not thereby lose their objective or unambiguous character. How objectivity may be retained during the growth of experience beyond the events of daily life. You might think that's a rather large issue. However, I think for Bohr, he saw that the events of daily life, or more particularly the everyday language that we use in communication, was largely taken over by classical physics, and of course precisified, but the same notions of reference and meaning were taken over into classical physics as we use in everyday life and everyday language. So experience beyond daily life is going to have as a subset of that daily life classical physics. And we can think, therefore, of Bohr's counter to classical semantics of truth and reference, is that the quantum postulate mandates revision of a rigid distinction between subject and object. Rigid distinction between subject and object, I'll say a little bit more about that, but it's essentially that the attribution of properties to an object belong to that object without contextual complications. We have already talked about the redefinition of the notion of phenomena in the quantum domain. And in the quantum domain, we note that Bohr requires that objective description must refer to the observations obtained under specified circumstances, including an account of the whole experimental arrangement. And that is the revised notion of phenomena, the expanded notion of phenomena that Bohr uses after 1935. And actually he uses it first in 1938 in a lecture in Warsaw, I believe. So let's look at that first quote, the problem of how objectivity may be retained during the growth of experience beyond the events of daily life. And here we see that the problem of objectivity has been transformed by that growth of experience, that is, beyond the experience within classical physics. And the problem of objectivity in Bohrian terms is the problem of objective description of experience with atomic phenomena. And any objective description demands the contraposition of subject and object. That's the playing field on which predication of objects or properties to an object is made. That's the playing field. In classical semantics, objectivity is straightforwardly a word-world correspondence. Objective description of experience in everyday life is just the representational semantics of direct word-world reference within ordinary language usage. In ordinary language, these terms refer to readily perceptible objects and relations. The Oxford philosopher Gilbert Ryle called this phytosemantics, after the dog and the dog's name. Objective description of experience in classical physics takes over this representational semantics of everyday language, but supplements it with precise, mathematically defined, unambiguous terms, so that physical states always have definite properties. The problem of objectivity is therefore the problem of subject, the attributor of properties, and object, the bearer of properties. So the differentiation between subject and object underlies the general limits of man's capacity to create concepts. That's a very general statement already in 1929. Because a subject refers to it and identifies an object through attribution of properties of concepts, the object is the bearer of determinate non-contextual properties with definite values independently of observation. And this is property realism, which is a paradigm of objective description of experience in everyday language, also of this representational property attribution underlying classical concepts of objectivity as word-world correspondence. This is what Bohr is attacking. He's going to mandate, because of the quantum postulate, a revision of the rigid distinction between subject and object. Remember, that's because because of the quantum postulate, there's no way of cleanly distinguishing between the target system of interest and the apparatus that's interacting with it through measurement. So that revision is going to reconcile two seemingly incompatible demands. These are stated most clearly in this paper of discussion with Einstein on epistemological problems in atomic physics from 1949, where the wholeness of the quantum postulate, this inability of non-separability of target system and apparatus, shows the fluidity of the subject-object distinction. He says this is an impossibility of any sharp separation between the behavior of atomic objects and the interaction with the measuring instruments, which serve to define the conditions under which the phenomena appear. Yet, unambiguous communication of experimental results requires classical concepts and everyday language, because this is description in terms appropriate to macroscopic human sensory experience. And so the distinction must be drawn, a fundamental distinction between the measuring apparatus and the objects under investigation. That second quote had to do with suspension in language. We're suspended in language. Our task is to communicate experience and ideas to others. We must strive continuously to extend the scope of our description, but in such a way that our messages do not thereby lose their objective or unambiguous character. And here the operative notion of objectivity is one of intersubjectivity. It's the ability of different users of a language to communicate. By users of a language, we're talking about people who are in the domain of atomic physics communicating what they learn in the lab. This objective description of experience, which is Bohr's notion for objectivity, is grounded in unambiguous communication of descriptions of experimental results in everyday language with suitable application of the terminology of classical physics. And this is basically to communicate what we have done and what we have learned. And that's fundamental in Bohr, that in some sense the subject is extruded from the cognitive agent and is put into the community of experimentalists and people who use atomic physics. Why the necessity of classical concepts? Well, the conditions of the possibility of well-defined property attribution and unambiguous communication of objective description requires ordinary language supplemented with kinematical and dynamical concepts of classical physics. And Bohr says this over and over again, but the clearest, I think, is in the 1949 paper. However far the phenomena transcend the scope of classical physical explanation, the account of all evidence must be expressed in classical terms. And there's always this puzzle in reading Bohr, why the emphasis on the necessity of classical concepts? It's because unambiguous communication must make use of the language that we get from our sensory experience with macroscopic objects. There's a fluid subject-object distinction, which is in some sense the core of Bohr's transcendental epistemology. He talks about the general epistemological lesson given by atomic physics. Quantum physics or quantum theory is going to show that the freedom of choosing the subject-object distinction, which provides room for the multifariousness of conscious phenomena and the richness of human life. This rigid subject-object distinction presupposed in classical physics, rigid because of the attribution of properties to objects as it were in themselves, wherein an object of knowledge is out there in the world with intrinsic properties, knowable by but independent of mind, is therefore revealed as a misleading idealization in classical physics from everyday experience. So I think that what Bohr is doing in these later papers is even saying that, well, you could have used this classical semantics of reference and meaning in classical physics. It got you along quite well, but actually quantum theory has taught us that the rigidity presupposed of subject and object enshrined in that classical semantics is questionable. And so I'm calling this small metaphysics. And I think of transcendental idealism in general as small metaphysics, basically limiting the claims of knowledge that we have to objects that are epistemically accessible to us. And that doesn't mean just the observed objects. It means observed phenomena. It means what we can infer with caution from those observed phenomena. Well, the small metaphysics here is objective description of experience means, in quantum physics, means that it's only indirectly representational. What do I mean by that? That the description by classical concepts mandated by conditions of epistemic accessibility and required for unambiguous communication, that's the description by classical concepts in quantum phenomena, implies that word-world correspondence can only be indirectly representational. That in some sense quantum reality is revealed, so Bohr is not an instrumentalist, but it's only revealed as filtered through the classical concepts that are required for human communication and understanding, which are descriptive of observation and experiment. And the quantum postulate implies the classical representational notions of objective description can no longer obtain, even in the case of non-disturbing measurements like an EPR. Here's just a summary. This elaborated, complex argument for objective description, the quantum postulate, the wholeness of interaction, hence the impossibility of distinguished apparatus and atomic system, implies that the subject-object distinction is contextual to conditions of epistemic access and well-defined description. And that will include, of course, a complete description of the experimental setup. Properties attributable to the object is only via reference to a complete description of the conditions of the experiment, preparation of the initial state, setup, which involves, of course, free choice of which observable to measure, and the concept of observation. Objective description mandates irreversible amplification, including permanent definite marks recorded by the apparatus. That's required for unambiguous communication. And objective description therefore demands unambiguous communication of results secured by the use of everyday language supplemented with terms of classical physics. It's worth pausing just for a moment on the controversy that Bohr and Pauli had about Einstein's conception of the detached observer. The detached observer for Einstein is someone who can actually ascertain the pre-existing values of physical properties or quantities without from a measurement. From the measurement you can infer back to the pre-existing value of the quantity. Einstein's ideal of the detached observer, Bohr says to Pauli in 1955, may be retained in quantum physics by recognizing we are always speaking of well-defined observation obtained under specified conditions. He elaborates on this in his paper Quantum Physics and Philosophy from 1958. The description of atomic phenomena has a perfectly objective character in the sense that no explicit reference is made to any individual observer, and that therefore no ambiguity is involved in the communication of information. No reference made to any individual observer because of the emphasis on unambiguous communication, the intersubjectivity requirement. Objective description of phenomena is a recording which is unambiguously communicable in common language without further creative treatment. We have here a subject without subjectivity. The subjectivity of the knower or the agent or the user of quantum theory is objectified in fashioning intersubjective, unambiguously communicable, complete descriptions of phenomena. And we've said that these descriptions necessarily use classical concepts and everyday language because that's the vernacular in which human sensory experience can be encapsulated. Bohr writes, all subjectivity is avoided by proper attention to circumstances required for well-defined use of elementary physical concepts. Unambiguous communication, this intersubjective objectivity, is only possible by use of everyday language, supplemented with classical physics terms. All right, summing up here, Bohr's transcendentalism is sui generis. It's not a priori, it's completely a result of the discovery of Planck's constant and what Bohr calls the quantum postulate. Descriptions of atomic phenomena are only about quantum objects under the specified conditions under which such objects are epistemically accessible. The conditions of epistemic accessibility, according to the quantum postulate, rule out descriptions of objects in themselves. And as Bohr writes in 1957, this was never published, but it's from a manuscript, the proper meaning of the words physical reality must refer to the content of an objective account of physical experience. And that really is what I mean by small metaphysics. An objective account of physical experience, both experimental arrangements and results of observations under these conditions, are expressed in unambiguous language with suitable application of the terminology of classical physics, once again. It's very interesting that Bohr was interviewed by Thomas Kuhn and another, I guess, a graduate student working for Kuhn, on the day before he died, on November 17th, 1962. And of course, Kuhn comes around to the EPR paper and Bohr's response to EPR. And a statement that has puzzled everyone, almost everyone, in the Bohr literature is that Bohr is quoted as saying, the whole idea of EPR is absolutely nothing when one really gets into it. You may think that I say it too strongly, but it is true. There is absolutely no problem in it. How can Bohr say that about the discovery, or at least the publication of a discovery of entanglement? And if you read Bohr's response to EPR in 1935, entanglement isn't even in the paper. It's all about how we attribute physical properties to quantum systems in the context of measurement, and how that has changed how we must think about semantics of reference and meaning. And that's what he's alluding to here. It's all about the semantics of reference and meaning and how that has been transformed by quantum theory in the quantum postulate. Okay, I'm going to wind up with a few slides on what I'm calling Bohr's small metaphysics as interpreted by John Wheeler. Wheeler was someone, who, as many of you know, who knew both Einstein and Bohr. Great master of general relativity and of quantum physics. And in 1955 he made this statement that complementarity, by who knows what he meant by that, I think he meant Bohr's philosophy, is the most revolutionary philosophical conception of our day. And I think what Wheeler had in mind is just this revision of property realism, classical semantics of reference and truth and meaning. Many of you know this diagram, schematic representation of the universe as a self-excited system brought into origin by self-reference. Okay. This is in the paper, Is Physics Legislated by Cosmology, that he wrote with G.M. Patton in 1975, published in 1975. But what Bohr is saying here is something a little different. No consciousness, no communicating community to establish meaning. I'm going to look at footnote 18, that's why it's circled, then no world. And here world is just Bohr's physical reality. That part of reality that's invested with meaning or information. Wheeler gets this concept of meaning from my ex-colleague, retired now, Dagfinn Folsdahl. Wheeler quotes this passage, at least of Folsdahl, at least in 7 papers from 1975 to 1992. That footnote 18 reads, the concept of meaning can be formulated, for example, in the words of Professor Dagfinn Folsdahl of the University of Oslo in his lecture in Meaning and Language series. Dagfinn spent a term at Stanford for 33 years in this. And what Folsdahl said there, meaning is the joint product of all the evidence that is available to those who communicate. There's a little gloss that goes on. Meaning is not something inscrutable that goes beyond empirical evidence. And how the interesting problem is how meaning is connected with the whole variety of human experience. That was Wheeler's concept of meaning when he said that we're investing without meaning, no physical world. Wheeler famously drew this diagram, capital R for reality, the iron post of observation holding up the paper mache that extends between observations, the net of theory. This is to symbolize the role of observation in the definition of reality, and that's Bohr's physical reality. Wheeler writes in Genesis and Observership in 1977, the results of observations and experiments regarding what we can communicate to others in plain language, what we have done and what we have learnt, quoting Bohr, serve as the iron posts of reality. All else is papier-mâché plastered in between them. I think that is pure Bohr. That's Bohr's view of the quantum formalism. Both Bohr and Wheeler emphasized the notion of phenomena. Wheeler famously said, no elementary phenomena is a phenomenon until it is a registered phenomena. Concentrating there on the irreversible amplification of results of experiment for communication. So a registered phenomena, unambiguous communicable answer to yes-no questions, famously the 20 questions of John Wheeler, and that gives rise to it from bit, for those of you who know that paper of Wheeler. The notion of phenomena introduced by Bohr to meet and overcome the objections of Einstein, that's true, it was to deny the elements of reality picture in EPR. And Bohr writes, reserving the word phenomena solely for reference to unambiguously communicable information, in the account of which the word measurement is used in its plain meaning of standardized comparison. Okay, finishing. Bohr's small metaphysics, and now I'm going to just take the question mark away and call him a transcendental physicist. Small metaphysics is reconfiguring word-world correlations in accordance with epistemic conditions, mandating contextual redefinition. Everyday vernacular semantics of reference and meaning for kinematic and dynamical terms, while taken over and precisified within classical physics, in quantum physics require contextual redefinition when applied to quantum phenomena. That's due to the quantum postulate, and are nonetheless necessary for unambiguous communication of objective descriptions of quantum phenomena. We started with the definition of the word transcendental, which and Kant's Copernican revolution, how to make the objects now conform to our cognition. Well, that's a consequence of the quantum postulate. It's not a consequence of any a priori structures of the human mind. The presuppositions of the possibility of knowledge of experience in atomic physics. These are presuppositions of unambiguous definition and communication of experimental results. Thank you for your attention, and great thanks to Hervé. Thank you.
Thank you very much, Tom, for this very clear and precise and complete presentation of Bohr's position, which had been accepted during decades by many physicists, even today, even if it's not clear if all of them had really completely understood what its content was, because Bohr's position, as you said, is subtle, and some points are not so easy to grasp, and that raised many questions. I think that we are going to have a conversation about that right now. So the question is now to the room, and thanks a lot for this very bright exposition. Thank you, Tom.
My question would be that to know if you would accept the idea of organizing both a priori in two levels. For instance, using ordinary language and classical concepts is a condition of possibility for quantum symbolization. But on the other hand, Kant's structure of sensibility and understanding are said by Kant to be conditions of possibility for the organization of a classical kind of objectivity. So would you accept this idea of a two-level, transcendental conditions, one which is directly, directed to quantum symbolism, and one which is in the background of the classical concepts that are themselves the conditions of possibility of quantum symbolism?
Well, I think there's a very strong analogy between the two, yeah. But I think they're very different insofar as you know, of course, these faculties of mind, sensibility and understanding, are a priori conditions of human cognition and human experience. I don't know that Bohr would ever have gone to that route. I've read many things, including your own very wonderful work on Bohr and Kant. There's no clear evidence that Bohr was ever a Kantian in the sense of, and you know this too. I'm not saying you know this very well. That Bohr certainly did not identify as a Kantian. He did not really identify as any ism at all. He, as I've tried to stress in this talk, I think he was a very highly philosophically inclined physicist, but without necessarily wanting to inject philosophy into his physics. I think that the quantum postulate forced him to inject philosophy into his physics. And that is a watershed, I think, for Bohr. And I think he spent the next 30 years trying to draw out in his own inchoate way the ramifications of that. So I don't know if that's an answer to your question.
Yes, perfectly. Just let me ask a very short, another short question. Would you accept that Bohr could have relations not only to the Kantian version of the transcendental, but also to the phenomenological version of the transcendental? Namely, and I have some elements, I think, that goes in this direction. First, his insistence on human experience, not experience in the sense of Kant, which is very organized, but just, lived experience. And second point is, his insistence on the picture of the blind stick, which is a prolongation of our body, right, of our own body. So blind stick represents for him our apparatuses, right. And but seeing apparatuses, experimental devices, as just prolongations of our body is very much in tune with some ideas of the phenomenology of the own body of the second Husserl and also, of course, of Merleau-Ponty. So I think there are some hints of phenomenology in Bohr.
Right. Well, there are certainly hints. As you know, and I think largely in response to Einstein, who was always critical of the subjectivity of quantum mechanics, that Bohr skirted any reference to individual subjects or individual consciousness. And so when we use the term experience in Bohr, I kind of think that the language that he uses means that it's in some sense the experience of a community that communicates with each other. And of course, that's an abstraction away from individual experiences, and how that transition from individual experience to community intersubjectivity is a great problem, also for phenomenology. Yeah.
Thank you, Tom. Alexei Greenbaum. Thank you, Tom, for this wonderful contribution to the ongoing competition of who, with regard to Niels Bohr, would take the same place as St. Paul had with regard to Jesus Christ. I have a list of questions, and of course, from the first slides of the talk, I was going to ask you about your use of the term information on some of your slides, but I think I'll leave that question for later, and we had talked about this before. I will ask you something else. I will invite you to make a thought exercise, if you like. Think about Bell inequalities. The Bell inequalities do not have a Planck constant in them. The Bell inequalities, published by Bell, as we know, just 2 years after Bohr died, in our contemporary view, talk about correlations. So there's a border between quantum and classical correlations, or classical and non-classical correlations. And then that's also bound later. Imagine Bohr started, or had started rather, not with all this baggage of Planck, old quantum theory, the quantum postulate with H constant, but from this distinction of between classical and non-classical, which is not based on the Planck constant, which is not doesn't play any role in Bell inequalities. Would we still arrive at this kind of small metaphysics?
Well, we'd have to have a lengthy discussion about the implications of violations of Bell's inequalities for non-locality. And that would be a long and I think we probably would agree. I think I've talked to you about that in other contexts. I think, though, that even when you're talking about statistical correlations at space-like separation, I think that the correlations are of what? Of spin up, spin down, something like this. What is spin? Is that an attribute of the individual system as it's often revealed to be, or is often thought to be in discussions of non-locality? Or is it something that involves contextualization of the notion of spin in the way that Bohr would approve?
Yeah, so you're following the line criticized by David Mermin when he said correlations without correlata. You know, lots of people, you're giving the answer about information about what, basically. This is what you're saying, right? So taking us back to objects, to the problem of reality. But is that line really a necessary, and is it really Bohrian? I'm not completely convinced that this kind of information about what question would be really the Bohrian way of thinking about this paradigm, because that would definitely be Einsteinian, yeah, right? But I'm not sure Bohr would go down that road, but I should probably let others speak.
Yes, many thanks, Tom, for this beautiful talk. I have a question on the relation between Bohr and another transcendentalist, founder of quantum mechanics, namely Heisenberg. I explain why. As Kant explains very well in the Metaphysische Anfangsgründe, the metaphysical foundations of natural science, classical mechanics, it is his great book on Newton. Classical mechanics concern a very specific class of phenomena, namely spatio-temporal motions. It is a core phenomena. The primitive phenomena is spatio-temporal motions. Okay. And all the initial debates in quantum mechanics with Bohr and others concern the fact that you were obliged to generalize the general concepts, metaphysical concepts of a phenomenon, observer, causality, etc., etc. And you explained it very well. How Bohr tries to enlarge, to modify, but at the general level, metaphysical level. The classical conceptuality of classical mechanics. But you can have a more radical transcendentalism, not at the level of concepts, principles, etc., but at the level of the core phenomenon you look at. And it is the case what developed Heisenberg. You change the core phenomenon. And in his great paper, 1925, Heisenberg reinterprets, it is the title of the article, he reinterprets the concept of cinematics, of dynamics, of mechanics, that is the transcendental moments of Kant, phoronomy, etc., with a new core phenomenon, spectral rays, no longer spatio-temporal motions, but spectral rays. This is the primitive phenomenon. And he constructed a new construction of objectivity in the sense of Kant, as our friend Michael Friedman explained it very well, with this new core phenomenon. So it is a quite different type of transcendentalism. No longer metaphysical, but at the bottom. So what were the relations of Bohr with Heisenberg and this idea that you have to change the basic phenomenon of physics? Mathematically, Alan Kohn, non-commutative geometry, insists always on the fact that it is the beginning of spectral geometry. You reconstruct classical geometry, but starting with another fundamental phenomenon. It's quite interesting, this two types of transcendentalism. I apologize for my English.
Very clear. It's very clear what you're saying. So if we turn to that 25 paper of Heisenberg, Umdeutung, reinterpretation of kinematical and dynamical concepts. You say, right. You are making the case that what Heisenberg has done is transcendentally changing the core phenomena from electron orbits to spectral information. Right. And I think you can read Heisenberg that way. I'm not sure that that was Heisenberg's intent, and I don't know if anybody would ever know if that was Heisenberg's intent. The way that Heisenberg, in the paper, describes what he's doing is essentially to base the theory itself only on observable phenomena, getting rid of non-observable electron orbits and things like this. And of course there's the famous, you know the story of tête-à-tête with Einstein, where he encounters Einstein in Berlin, and he explains to Einstein, and he even says in the paper, what I'm doing is what Einstein did in special relativity with relativity of simultaneity, to base the notion of simultaneity on something that we can observe, clocks that are coordinated at distance. Right. So Einstein, what I did was what you did in 1905. I've built a physical theory. I've tried to build a physical theory. I think try is probably the operative term, using only the data of observation. I think the paper lends itself, and certainly in the philosophical literature, most of the philosophical literature lends itself, certainly logical positivists thought that this was almost a perfect rendition of positivism, Machian positivism, basing a theory only on the observable. That is a reading of the Heisenberg paper, and I know that it's your reading. I know that it's Alain Cahn's reading. It's an interpretation of that paper. It's also interesting that Heisenberg goes from that position to much later to this idea about potentia, which is Aristotelian in its metaphysics, right? And as untranscendental as can be. Yeah.
Bohr died 2 years before Bell's inequalities. Yeah. And as you mentioned, it is always said, and till the end of his life, that the EPR correlations are not a problem. This is simple. This is easy. Well, that's the quotation you made. There is no problem with that. That's simple. Okay. Of course, that's not something that which Einstein was satisfied, because he refused that. But 2 years before Bell's inequalities, it was strange to say it's simple, because it's not simple. Today, we have Bell's inequalities, we have the results, and we know that, okay, that's true. That's true in the sense that Bell's inequalities are violated, which was not obvious at the time of Bohr. It could have happened that they were not violated. It could have happened. And Bohr never knew that. He died before. So saying that there is no problem seems a little bit puzzling, because it's not easy to swallow that. And today we have roughly two kinds of positions about this problem. The first one is just to say, okay, we have non-locality. It is what many physicists accept. And they say, okay, there is non-locality, we have to accept that the nature is like that. And we have no question, this is not violating relativity, we cannot transmit any information with that, so there is no problem. I think that it's a little bit worrying to just be satisfied without any further question about that, because that's not so simple to understand. And the other position is the position coming from other interpretations, like cubism, like my interpretation, the convivial solipsism, which is to relate the measurement to one observer, and to make the observer, the measurement relative to one observer, because in this case, you have no problem with non-locality, and you can understand the correlation as linked to the observer who is doing the measurement. And that's another possibility, which is rejected by many physicists also, because they don't like this notion of measurement that is linked to an observer. But there's two positions, and I still don't understand how it's so easy to say, okay, that's easy, that's simple, I accept that, without any further question. And I can't understand that Bohr was so at ease with that. So why was he so confident in this position that is not very easy to take?
Well, of course, he's not referring here to violations of Bell's inequality, as you know, it came later. The way I read this passage is that it's all about contextual attribution of properties. Okay, maybe that's right, maybe that's wrong. What I can say about Bohr is, what would he think of convivial solipsism, cubism, and what would Bohr look like with subjective probability? It was not something that Bohr, I think, would have readily adopted, because of his absolute abhorrence to any particular reference to an agent or to a user of quantum theory, if you like. On the other hand, if you come at Bohr from the direction of De Finetti or something like this, and you believe that subjective probability is the fundamental notion of probability, can you unpack Bohr enough to get all of this stuff that Bohr is really interested in, the small metaphysics as well, the violations of Bell's inequality, and the contextual attribution of properties from the agent in the situation of measurement and updating, Bayesian updating, something like that. And that's a big program. I don't know that it could be carried out, but I don't see any, in principle, reasons why it couldn't be carried out.
You insisted that Bohr would have rejected this idea of a purely individual, subjective approach of the phenomenon. But I think we should not forget that he went to this almost objectivist position about devices, about experimental operations, and so on, under the pressure of the Soviet physicist Vladimir Fock, who said, in materialist, in dialectical materialist ambience, we cannot accept your subjectivism, and therefore you have to retreat from that. And Bohr did that.
Right. No, I know that. I know that story. Yeah. Yeah.
Alexander Afriat, University of Western Brittany. So it's a follow-up to the second last question and the screen. So your response was, well, how can he say that entanglement is a piece of cake, it's no problem, and then you said, well, there's no explicit reference to entanglement in the EPR paper. And so there's this issue of entanglement and the EPR paper, which is non-trivial. And so my comment concerns that.
No reference in Bohr, in the response of Bohr in 1935.
So this is my so the criterion EPR use to identify an element of reality, you know, if you can predict with certainty, in other words, probability equal to 1, blah blah blah. So to apply that condition once well, that's kind of trivial, and it does not require entanglement. But of course, they need to apply it twice, and this comes back to your because otherwise their argument is completely trivial. So they've got to apply it twice. So you need a double Schmidt decomposition, and that of course requires entanglement.
Mm-hmm. Mm-hmm. Okay, well, I accept it. You know. Obviously, they have to apply it twice because of the free choice criterion that it you know, whatever observer at station 1 chooses to measure on station 1 can predict the corresponding quantity over here, can predict it, and since there's free choice of which non-commuting observable to predict, you need the double Schmidt decomposition.
One commuting,
yeah.
So that's where the entanglement is absolutely necessary.
Yeah, I agree.
I just had a quick comment, not about Fock, we can talk about Fock another time. You know, I think it's much more, if you like, pedagogically clear if you ask yourself not so much what Bohr would have thought about entanglement in terms of Bell inequalities, but why and Specker went on such a different way that is completely incompatible with Bohr in terms of Cohen-Specker contextual. Remember, Specker begins during Bohr's lifetime. So this is not like 2 years later or whatever, right? And what Bohr would not even have conceived, I think, is this important Specker's question. Imagine there are all these different observables that have values, even if we don't know them, but they are value defined, right? They're value definite. So for Bohr, this would be inconceivable, because each observable would come with its own context, and he would be completely unable to even talk about having 37 observables with definite values, because this cannot be done with one context. So I think if we want to sort of pin down the fundamental gap between Bohr's contextualist view of reality and what happened in the 60s, we can just for pedagogical reasons, I think, we can start with Specker and contextuality, and it's so clear why Bohr cannot even interpret that.
Jean Sass, my question is, what is the status of irreversibility into the logic that you presented? The word appeared only once. You need an irreversible process. So what is the irreversibility status in the reasoning, in the line of reasoning of Bohr?
The irreversible amplification is the term. I think that's the only context in which Bohr uses the term irreversible. It's just this condition of intersubjective objectivity where the results of experiments have to be recorded so that they can be communicated. And otherwise it doesn't count as objective description of the phenomenon.
It is a new principle, which is, it's an add-on in the logic of the whole presentation. Am I right if I say that?
Well, I don't know. I think that there is a missing step between what goes on in the lab to what's communicated to others who are in the world of quantum phenomena doing experiments. And what is communicated are the results of experiments, and the results of experiments are in some sense recorded, described in a certain sense, right, in objective terms. And that's what ensures this intersubjective notion of objectivity that Bohr places at the center of the new version of this referential semantics that he's using.
So any other questions, or do we close the session? Okay, so thanks a lot.
Well, thank you.
Thanks a lot.
Thank you for your attention.